All right, what is up, everyone? It is problem number 14 of the MIT Integration Bee from 2018. Here we have the integral of the sine of 2x. Ooh, yay, I get to use my double angle identities. Minus the sine squared of x all over the cosine of 2x, again, double angle identities, minus cosine squared x dx. Let's go ahead and get started. So whipping out my double angle identities, I know that the sine of 2x is going to be equal to 2 sine x cosine x. So I can rewrite this integral. So sine of x is equal to 2 sine x cosine x. And I can subtract that from the sine of x squared. So minus sine, or not the sine of x squared, but the sine squared of x. Or the sine of x quantity squared. Okay, now we're moving on. We're going to say the cosine of 2x, and I have a couple options to choose from. I think the most concise option is going to be this cosine squared, or is going to be this cosine 2x is equal to the cosine squared minus sine squared. And that's because if I have this cosine and this minus cosine of both numbers squared, they will cancel out. So I'm going to try and use that one so I can get them to cancel out. So I'm going to say that cosine of 2x is equal to cosine squared x minus sine squared x minus cosine squared x. That's dx. Great. So here's what we can do. We can say, like we wanted, that cancels with that. And now we can split this into two different integrals. We have this is on the top. It's this quantity A plus or minus quantity B over one quantity. If it was, so if I have A plus or minus B over C, I can split that integral. But if I have A over B plus or minus C, I cannot split that integral. That's just because it's not a quantity that you can split into two different fractions. Whereas, A plus or minus B over C, you can split it into A over C plus or minus B over C. But it's not the same the other way around. Awesome. Cool. So keep going with my nice orange here for fall because it's that time of year. So what are we going to do? Let's go ahead and say I'm going to split the integral, and I can factor out a sign out of that one. So I can say it's going to be negative 2. So I'm bringing out that negative there and that 2 there. And I'm factoring out one of the signs. So I have cosine over sine dx. That's pretty fun. And that all went away, and that all went away. So now I'm going to work with this. I have two negatives, so that's a positive. And I have sine squared over sine squared, which is just 1. And that's just bringing across the dx. All right, so we can go ahead and move this in, move it out, move it down. So I'm going to go ahead and say for this one, I'm going to use a u sub, u equals sine x. Du is just going to be the numerator, which is cosine x dx. So I can make my integral is negative 2 times the integral of 1 over u du, which is negative 2 times the natural log of absolute value sine x plus this x over here, because dx integrates to x, plus c. Or I can kind of rewrite this as x minus 2 natural log sine x plus c. And that is my final answer. Good work.